Okay, guys, day 3. So we are going to be going over soil characteristics and properties. So first we got to say, what is soil again? Soil is a combination of many, many things. So this shows you the weathering down. So remember, we have to weather down bedrock, to make that soil fine enough so then living things can start to grow. They break down that rock even more and add organic matter in. And now we're starting to form those soil layers, right? That was in succession. If you don't remember that, stop this video now, go back and re-listen to the other videos. But these are the 5 things that make soil: living things, organisms, topography, where it's located in the world, the climate of that area, the parent material or the bedrock that makes up that soil, and time. And don't forget, there's things like air and other things that go into it. So again, here are the things that over time make all of our soil properties: the parent material, the climate, the topography, the organisms, and time. So soil texture. Soil texture refers to the weight proportion or percentage of the things that make up that soil. So what percentage of sand, silt, or clay, which we're going to go over soon, don't worry. The minerals that are in there, the particle sizes, how it feels, how it holds water, all of these things make up the soil texture. Even things like color, pH, everything that goes into soil makes up that soil texture or your end result. So first we're going to talk about grain size. Sorry, let me gather my thoughts here. Soil sizes are extremely different. Gravel is by far the largest. So anything that is larger than 2 millimeters is considered gravel. Its second largest is sand. Sand, believe it or not, is massive. If you look at the size relatively here, sand to silt and then to clay. So these are the 3 main types of soil. These 4 right here are what we're going to be using in our labs. So gravel, sand, silt, and clay. So yeah, look how crazy this is. Sand is massive. Then we have silt, and then finally, look how small clay is. And gravel would be like out to here. All right, so gritty versus fine, you need to know what these words mean. Sand is considered a gritty soil because it feels gritty. I know that sounds silly to say, but if you imagine taking a handful of sand, I know the majority of you have probably been to the beach, and rubbing it against your skin. Doesn't feel pleasant. It hurts. That's that friction causing abilities. Clay is considered fine because of its smoothness. Clay is so small that when it rubs on you, it feels smooth. You don't feel that friction causing abilities because it's so small. So soil color, what does it mean? Yellow or red means that there's iron in that soil. So like here and here. Dark brown or black indicates the soil has a high organic matter content. That's good. That means the soil is nice and fertile. So like here and here. Wet soil always appears darker than dry soil, but the presence of water also can cause a higher oxidation or rust rate. So believe it or not, if a certain soil does get wet, like clay, it actually increases the ability for that iron oxide to happen, which can cause it to turn red, like this. The color tells you what nutrients are present in the soil. That's the whole point. You want a dark brown, but red's not necessarily bad. It just means there's a lot of iron. But you don't want the light. Light means there's not a lot of nutrients in it, and it's not super healthy. But the color dictates what nutrients, let me say that backwards. The nutrients dictate what color. So here's just a bigger picture showing you the different colors possible. All right, so again, what makes soils red? There's a lot of iron in the soil. This soil holds onto water really well, which allows the chemical reaction to occur with iron. Remember what I said before? That water allows that chemical reaction to occur. So clay will turn red because clay has lots of iron. Clayton was named after this. Clayton has a ton of clay. So look around. You'll see a lot of this red soil here. What makes soil brown? Life. Organic material, life. Things made up of things that make up biotic things. So this soil is fertile. It grows, I can't get rid of this now. So this soil grows a lot of things really well, and it is available for gardening. Think about when you buy soil at the store, it's always like a black color or really dark because that means there's a lot of dead plant and animal matter in it. And I know that's gross, but that makes soil good. So the more nutrients means the more dead stuff that was in there. And once we have dead plants, then we need things like decomposers, like the worm shown, or bacteria, or fungi. And they break down those dead plants and animals into the nutrients that make that soil super fertile and healthy. And we want fertile, healthy soil so we can grow more living things. That's the whole point. Here's some examples of that dark organic humus. That's what we're going to learn. So it's called humus soil. All right, deposition. This was a vocab word. This is what happens when there's iron in the soil that either cannot be used by plants or there's no iron in the soil. No iron is bad. This is what happens. It actually can cause your plants to turn yellow. Gardeners, this is a gardener's nightmare. But plants have adapted that sometimes when the iron is in a weird form, what they'll do is they release this acid that will convert the iron into a form that the plant can then use. And that is soil chemistry. And that's what deposition is called when it's talking about soil chemistry. All right, aerobic versus anaerobic soil. Aerobic means there's oxygen there. Anaerobic means there's no oxygen there. So what do you think is better? Oxygen. We need oxygen. Living things need oxygen. So, but sometimes living things in the soil like bacteria or those other microorganisms take that soil away. Take that oxygen away. What's going to happen to the living things if there's no oxygen in the soil? It's not good. And when they go away, what about the fertility of the soil? Yep, you're right. That also goes away. So that's a big problem. So how do we fix that? How do we add oxygen back into that soil? We put better microorganisms in. So we put better decomposers in, and that will increase that oxygen level. But sometimes the bad microorganisms can take oxygen away and make that an anaerobic soil. All right, so soil characteristics, the different types. Oops, you cannot see the words there. I will fix that. You'll be able to see them when you look at your notes. Sand is the largest. Feels gritty, it doesn't bind well, it's easily eroded or washed away. It's formed from the weathering down of shale, limestone, granite, and quartz. Silt, it's finer and smoother than sand. It holds water better than sand. It's better for farming. It's heavier than sand, though. And it's formed when fine sediments like dust, organic matter, and debris are carried by water or ice and then cemented or pushed together over time. It's small, but this is the stuff when you touch, it leaves stuff on your hands. It leaves a residue on your hands. Clay, finest, binds extremely well, holds on to water extremely well.
May I have attention, please? The school will be closing
Sorry,
in
guys.
15 minutes.
Hold on.
Now repeat, the school's going to close in 15 minutes. Thank you.
Hear that? They're going to kick me out in 15 minutes. Okay, so it has little to no air spaces. It's extremely sticky when wet, but you can take clay and mold it into shapes and then let it harden, and that's how you can get those cool ceramic the dishes and stuff, or the art pieces. You use clay. You guys use it in your discovery too. But clay forms when rock is in contact with water, air, or steam at a constant level. So again, this is just showing the characteristics of these types of soil. You do need to know them, so go ahead and study them. And then finally, the soil triangle. So you use this to determine how much of each of a soil sample may have. So you're going to go outside and take a sample of soil here soon, and then you're going to actually try to measure the percentage of what that soil, when you look at the sample and look at this. So if we say like it is 50% clay, but let's say 10% sand, so that goes all the way, down here, and we'll say 40% silt. So we're living in that clay realm, right? So you can use it various ways, but don't worry, I'm not going to do that right now. All right, go fix your pretest. Fix your pretest, fix your pretest, fix your pretest. If it's in my room, come and grab it. You can either keep it in your new room or just keep it in mine and then just continually come and grab it when you need it. That's totally fine. Then you're going to start your poster about soil. It will be your pick on which one you do, but make sure you follow the directions on the other paper. Okay, guys, good job.